So let's solve another problem. The problem says that a stockroom worker pushes a box with mass 16.8 kilograms on a horizontal surface with a constant speed of 3.50 meter per second. The coefficient of kinetic friction between the box and the surface is 0.20. What horizontal force must the worker apply to maintain the motion? So, in order to solve this problem, again, the first step that we have to do is to draw the problem. So you have a box on a horizontal surface. So you have a horizontal surface and a box. And then, it is being pushed by a stockroom worker. So let's draw a person here. Okay? And then, it is traveling in a constant speed of 3.50 meter per second. So let's just assume that it's moving to this direction, and then the velocity is 3.50 meter per second. Now, it says here that the coefficient of kinetic friction between the box and the surface. So you're also given a coefficient of kinetic friction, which is 0.20. Now, we are being asked about the horizontal force that the worker must apply to maintain the motion. Okay? So, the next thing that we have to do is to identify the given parameter and then the required. So, you are given the constant speed, you are given the coefficient of kinetic friction, and you are also given the mass of the box, which is 16.8 kilograms. Okay? So, what is required of us is we must find this horizontal force P. So, we have to find this force P. Let's just call it P right here. So, what is the value of that force? The third step is to draw the free body diagram. So, before drawing the free body diagram, let us first identify the forces that is existing in this system. So, since we are observing this box, that would be our reference point. So, let's draw a dot on the middle. Okay. So again, when an object is in contact with any surface, it will automatically have the following forces. You will have your normal force and you will have your frictional force. Now, please also take note that all objects contain or has a weight. So let's draw first your weight. And how do we draw your weight? Weight is always drawn perpendicular to your ground. And since this is your surface, and this is also your ground, since this is a horizontal surface, simply draw it moving downward. Okay? Now, another force, and let's call this one your weight. Another force that is existing is that you have your normal force. Normal force is drawn perpendicular to your surface. Again, this is your surface and this is also your ground. So just move it, moving upward. So please take note that your normal force is always drawn upward. So it is always the pushing force given by your surface. Another force that we have is your friction force. And again, we draw your friction force parallel to the surface and then having the opposite direction of the motion. So if our motion is moving to the right, then your frictional force is moving to the left. So this will be your frictional force. Okay? So, and then you already have your pushing force. Now, therefore, those are the forces that is existing. Then, transforming it to your free body diagram, I'm gonna draw the coordinate system. Okay, so pushing force is moving to the right. So, let's call this one your P. Then, normal force is moving up. So, you have here N. Then, you have frictional force here. F. And then, lastly, you have your weight. Okay. So, please take note that we can solve for your weight. Weight is equivalent to mass times acceleration due to gravity. So, the mass is 16.8 kilograms multiplied by 9.8. So, you have 164.64. 164.64 newtons. Okay? So again, don't forget to place the angles of your forces. So the angle of your pushing force is 0. The angle of your normal force is 90 degrees. The angle of your frictional force is 180 degrees. And then the angle of your weight is 270 degrees. Okay, so we're done drawing the free body diagram. Let us now identify the applicable Newton's laws of motion. You have to look for the key terms. So what are the key terms here? So as you can see, it says here that it is in constant speed. So if it is in constant speed, therefore, it is under the Newton's first law of motion. So constant speed, therefore, its first law. So therefore, summation of all forces is equivalent to 0. Okay? Now, the next step is to execute your solution. So how do we do that? The first step is to find the components of each force. So let's find the components of each force. Let's start with P. So you have Px and then you have Py. So P cosine 0 and then P sine 0. You have normal force. So Nx, Ny, N cosine 90 and sine 90. You have F. So Fx, Fy, F cosine 180, F sine 180. And then lastly, you have your weight. So you have Wx and then Wy. So W cosine 270 and then W sine 270. So let's calculate for the angles. So you have cosine 0, 1. So therefore, P times 1, that is P. Sine 0. So you have 0. So P times 0, that is 0. And cosine 90. So cosine 90. You have 0. So 0 times n, that is 0. And sine 90. So sine 90. You have 1. So 1 times n, that is n. You have cosine 180. So cosine 180. That is negative 1. So negative 1 times f, that is negative f. Then sine 180. So sine times 180. Sine 180 is 0 times f, so that is 0. Okay? Next, so we set all the components of force. So let's have summation of forces x equals 0. Summation of forces y equals 0. Okay? So summation of forces F. So you have Px plus Nx plus Fx plus Wx equals 0. So Px is P. Nx is 0. Fx is negative f. Wx is 0 plus 0 equals 0. So transposing your F, you have the pushing force is equivalent to your F. Okay? So since we have a friction, because you have the coefficient of kinetic friction, please take note that the formula for your friction is equivalent to F is equivalent to mu N. So you need to find your normal force because the coefficient of kinetic friction is given as 0.20. Then, and how do we find that? Then let's use the other formula. Let's use the other equation. So you have summation of forces y. So you have Py plus Ny plus Fy plus Wy equals 0. So Py is 0, Ny is n, Fy is 0, Wy is, we did not solve for this one. So cosine 270, so that is 0. Then sine 270, that is negative 1. So you have negative 1 times W, so negative W. Negative W equals 0. So transposing your weight, you have N or normal force is equivalent to your weight. And we have the value of weight, which is 164.64 newtons. Okay, so you can now substitute to solve for your pushing force. So P is equivalent to mu n, and mu, or coefficient of kinetic friction, is equivalent to 0.20 multiplied by the normal force, which is 164.64 newtons. So your pushing force is equivalent to 0.20 times 164.64, and that will give us 32.928. 32.928, or you can simply say that the pushing force is equivalent to 32.93. Don't forget the unit, which is your newtons.